we are going to talk about some special angles that we can evaluate trig values on. So in these problems, we're going to have a few things that we need to have kind of memorized. The first one is a special triangle that is called a 30, 60, 90 triangle. So mathematicians are not often super creative in coming up with names, so it's called the 30, 60, 90 because that's how big the angles are. The sides will always follow a particular pattern of across from the 30 is a 1, the hypotenuse is 2, and across from the 60 is a square root of 3. Now, we could take this triangle and kind of blow up its lengths, but if we do so in such a way that the angles still stay the same, then all the sides are going to increase or decrease proportionately. So it's kind of like putting it through a copy machine and making it double size. When you do that, the angles will not change, but the sides would all double size. So then it'd be 2, 4, and 2 times the square root of 3. Okay, so we could double it up and blow it up, but this is kind of the basic pattern, is this 1, 2, and square root of 3. Then we have a second triangle that is called our 45, 45, 90 triangle, again, because that's how big the angles are. And its sides follow the pattern of 1, 1, and a square root of 2. And again, we could take this triangle and put it through the copy machine and blow it up so that everything would be double size or triple size, or we could shrink it down so everything is half as big. But the angles will stay the same. The sides are what's going to grow or shrink. Okay? Then something else you need to know is what we call our unit circle. Our unit circle is called the unit circle because we're going to say it has a radius of 1. So if the radius length on this is 1, then that means that this point over here would be located at 1, 0. X, y, it's over 1 unit because that's how big the radius is, and it's up 0 because it's still right on that axis. Then this point up top is going to be over 0 and up 1, again, because that's how big the radius is, so it's up 1. Over on this side, we're going to have a point that's at negative 1, 0, negative 1 on our x-axis, but up 0 on the y. And down at the bottom, we're going to have a point that's over 0 and down 1. Okay, so might be wondering, like, what does this have to do with trig, right? The triangles, okay, triangles, we did right triangles like SOHCAHTOA, and that's what we're going back to today is SOHCAHTOA. So we took a little detour and we talked about triangles that were not right triangles, and we did our law of sines and law of cosines, but we're going back to SOHCAHTOA now in these right triangles, these two special right triangles. But then we have this unit circle as well. So this unit circle tells us about trig values measured for certain angles. So we always begin at our positive x-axis to name our angles. So we're going to say this is 0 degrees over here. So think of it like a hinge. I don't know which way the video goes, but keep it like a hinge. And then 0 is at that line, and then we're going to start opening up the hinge. And when we measure angles, we always go in a counterclockwise direction. So measuring counterclockwise from here, coming around, then up top we would be at 90 degrees. Keep going around counterclockwise. We hit 180. Keep going around. At the next line we hit 270. And then if we go all the way around, we hit 360 degrees, makes a whole circle. Okay? So those are some angle lines. Now, these points that hit on these angle lines, they actually give us two very important pieces of information. They give us the cosine and the sine. And it's nice and alphabetical. C, S, just like X, Y, right? X, Y is alphabetical, so is cosine, sine. So these give us the cosine and the sine values around at those angle lines. So we could also measure in radians. So in our last lesson, we learned about radians. I think it was the last lesson. Maybe last lesson, we learned about radians, and we learned that 180 and pi is our conversion factor, which is like the 12 inches equals 1 foot. So this 180 degrees, that's the same thing as pi radians. Well, 0 is the same as 0, and 360 is 2 180s, so that would be 2 pi. Then as we're going around the circle, what's halfway between 0 and a pi? A half of a pi. And so we write that as pi over 2, a half of a pi. So we've got 0, we've got a half, we've got 1. Down at the bottom then, we would have 1.5 pi's, but we write it as 3 pi over 2. 3 over 2 is 1.5. So 3 pi over 2 is 1.5 pi's, and then keep going, and we had our 2 pi. So 0, a half, 1, 1.5, 2 pi's going around our circle there for radians. Okay, so these pictures are really, really important to what we're doing today in our study of trig with special angle values. Okay. Also, some helpful conversions for you. Thinking about this radians and degrees thing like we did in the last lesson. So those two triangles up top are being measured in degrees. 30, 60, 90, 45, 45, 90. Those are all degrees. It is helpful to know conversions that 30 degrees is pi over, well, let's figure it. So pi is like 180. 180 divided by 6 is equal to 30. So that's kind of a helpful thing to know, that 30 is equal to pi over 6. 60, okay, pi is 180. 180 divided by 3 is equal to 60. And then for 45, oops, I don't want to write 180, I want to write pi, but we think of it as 180. 180 divided by 4 is 45. So those are some helpful conversions to know. So in that last lesson, we learned how we could kind of convert any of those angles. These are ones that are going to come up frequently, so they are helpful to have reference. All right, so what are we going to do with all this? All right, so let's look at an example. In an example, let's say that we wanted to find the sine of 135 degrees. Okay, so what we're going to do is we're going to start by graphing the angle. So when we graph an angle, we begin at our 0 line, and then I'm going to go around counterclockwise 135 degrees. Well, 90 would be straight up, so I'm going to go 90, but I have to keep going if I want to get to 135, and I'm going to figure out it's going to be somewhere in here, somewhere in between 90 and 180 is where we would find 135. Well, where in between there? So if I do 180 minus 135, that would tell me how far away that line is, that angle line, from the 180. So if I do a subtraction here, I get 45. So I get a 45. Oops, I wrote a 5. Get a 45 degree angle right there. Okay. Now, when we do this and we're talking about our special angles, it should always turn out to be one of these special angles. So if you subtract and you got like 25, you probably did it wrong, because we don't know about 25 degrees. But we have some triangles that tell us about 45 degrees. So what we're going to do is we're going to drop that down and we're going to make a triangle. When you drop down, always, 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 always connect to the x-axis. Okay, so what axis do I connect to? The x-axis, always. But what if, no, always the x-axis, every time. Always connect to the x-axis. Okay, hopefully I've emphasized that enough. All right, now the sides of this 45, 45, 90 triangle are, according to the pattern, 1, 1, and a square root of 2. But because this is on a graph, we want to think about like positives and negatives. So on our x-axis, the x-axis goes positive over here and negative over here, right? As we think about graphing, we graph positive out to the right and negative out to the left. So that means that that one is actually a negative 1. Now for our y-axis, we got, positives up top and negatives down bottom, and that 1 is going in the upward direction. So that's a positive 1 for the vertical one there. The hypotenuse, always positive, no matter what angle it looks like it's going, no matter what direction it looks like it's going, hypotenuse, always positive every single time. Okay? So now our triangle's labeled, so then we are ready to tackle the question of what is the sine of 135? Well, SOHCAHTOA, sine is opposite over hypotenuse. So looking at that origin angle, always look at the angle that's by the origin there. So that 45-degree angle that's by the origin, opposite is positive 1, hypotenuse is square root of 2. And that would be our sine of 135 degrees. If we do a cosine of 135, well, we use the same picture because 135, we already have the graph of what that angle looks like. But the difference now is for cosine, we want to think of SOHCAHTOA adjacent over hypotenuse. And now adjacent to that origin 45 angle is the negative 1. And hypotenuse is square root of 2. So now our answer would be a negative 1 over square root of 2. Okay, we could do a tangent. We could do a tangent of 135. Tangent, we learned, is TOA, opposite over adjacent. So opposite of that origin 45 is a positive 1. Adjacent is a negative 1. So for that, we would get an answer of negative 1. Okay, so we get all of those answers from that triangle. Okay. Now, some teachers teach this all according to the unit circle. So looking back down at that circle, if I added in a line at the 135-degree mark here, well, this side is 1. And so then if I make that triangle, well, I could relate it to that pattern of the 45, 45, 90, but the hypotenuse is 1. So I have to think about, well, square root of 2 divided by what would give me 1? Well, you divide anything by itself as 1. So it's a dividing by a square root of 2. So then the sides are 1 over a square root of 2. This is a negative 1 over a square root of 2 because it's on the negative side. And then that gives us, alphabetically, if I think about this point here, it's over and up values give us the cosine and the sine. So we could get these off of the triangle, but because you have to do that division and adjust, I personally find it easier to just graph the triangle for itself and not worry about trying to put it into the unit circle. But some teachers may teach the unit circle. I'm not sure how Mr. Khan does it. So if you watch the Khan Academy videos for help or look at their hints, I'm not sure if Mr. Khan uses the unit circle to do it or not. So that's kind of up to you if you want to look at it that way. Or Mr. Rohr, Mr. Hoffman might do it that way as well. But I just stick with those 2 triangles up top for my answers here. So let's go ahead and try another example. I know this is really tricky stuff. I would love to be able to see your faces and see like the head nods or the what is she talking about looks, just because I feel like I could use some feedback from you to know if this is making any sense at all yet. But we'll just keep going with it. Let's say that I want to define my trig values for negative 210 degrees. Okay. Negative 210 degrees. So the first thing I'm going to do is I'm going to start by graphing that angle. So I'm going to set up my axes. Now we always, every single time, begin in the same place, and that is at that positive x-axis line. That's our 0 line. So that's always where we begin measuring. Now, because this angle is negative, I'm going to go backwards around my circle. So I'm actually going to go in a clockwise direction. So as I go around clockwise, I'd hit 90. I need to keep going. I'd hit 180. I need to keep going. Well, how much do I need to keep going? How far is 180 from 210? It's 30 more degrees. So I can do a subtraction there. So 210 minus the 180 gives me a 30-degree angle. Then connect to which axis? The x-axis. Every time connect to the x-axis. Make sure always connect to the x-axis. Okay, now this is our 30, 60, 90 triangle. The pattern of 30, 60, 90 is across from the 30 we find a 1. On the hypotenuse we find a 2. Across from the 60 degrees we would find a square root of 3. And I didn't label the 60 degrees, but it's the one that's not 30 and not the right angle. Okay? So across from the 30 we find the 1, the hypotenuse is 2, and across from the 60 we find a square root of 3. But now we need to think about directions. So as we think about our x-axis, positive over by that red arrow, this is the other way, so negative. As we think about our y-axis, that's an up, so that's going to stay positive. Hypotenuse always positive, no matter what direction. Okay, so now that our triangle is labeled, we're ready to SOHCAHTOA. So I kind of use that like a verb. So we're ready to SOHCAHTOA. Sine is opposite over hypotenuse. So we're looking at that 30 degree, always look at the angle that's next to the origin. Opposite of the 30 degrees is 1. Hypotenuse is 2. So our answer is 1/2. Okay. We could also do, because we already have this triangle drawn, a cosine of negative 210. Okay, well, cosine for SOHCAHTOA, so so that's adjacent over hypotenuse. Adjacent to that 30 degree, we always look at that origin angle, 30 degrees, adjacent is negative square root of 3. Hypotenuse is 2. We could do a tangent. Tangent of negative 210. We do a tangent here. Tangent is TOA, so that's opposite over adjacent. Opposite of that 30 degrees is 1. Adjacent is negative square root of 3. Okay, so we can find all of our trig values there within that one. All right, let's look at another example. This time we'll look at a radian problem. Let's look at, say we want to find the sine of 7 pi over 4. 7 pi over 4. Okay, so we're going to start by graphing it. If we're measuring in radians, we still begin out to the right as being our 0 line, but we said that on the other side that would then be pi, right? Because 180 degrees, pi in radians. Okay, so that bottom number tells us how we're going to cut the slices. So we're going to cut each pi into 4 pieces, pi divided by 4. Okay, so we're going to take pi and we're going to divide it into 4 pieces. Pi is half of a circle. So we're going to cut the top half of the circle into 4 equal pieces. So 1, 2, 3, 4 pieces. Then I can do the same thing on the bottom. I'm going to cut the bottom into 4 pieces. I'm going to call them 5, 6, 7, 8. Okay? All right, so we cut according to the bottom number each half of the circle, because that's what a pi is. A pi is a half of a circle. So each pi we cut into 4 pieces. Now we're ready to count out to which piece we want. Because it's a positive, we're going to go around counterclockwise. So I start at my 0 line and I count 1, 2, 3, 4, 5, 6, 7. And so my angle lands on this line right here. 7 pi over 4. We went around 7 pieces. Connect that to the x-axis every time. X-axis every time. Now we want to think about what angle we have in there. Well, if we divided pi, or 180, into 4 pieces, 180 divided by 4, each of those angles is 45. That's that pi over 4 is 45 degrees. That's that conversion that can help us out. So we got a 45, 45, 90 triangle here. I'm going to erase that 8 because I don't want us to think that's how long that side of the triangle is. It's not. That was just the 8th piece. So the sides of the 45, 45, 90 are 1, 1, and square root of 2. Now as we think about direction on the x-axis, that 1 is heading over to the right. That's the positive direction. As we think about the up-down, that's below the x-axis. That's going to be a -1 for our vertical one there. Hypotenuse, always positive, no matter what direction. After your triangle's labeled, you are ready to SOHCAHTOA. Sine is opposite over hypotenuse. Opposite of that origin 45 is -1. Hypotenuse is square root of 2. Okay. Earlier this year, we talked about square roots on the bottom of a fraction, and we said it's kind of considered like inappropriate or that we should fix it. With trig, we usually just let it go. So we're going to leave our square root on the bottom of the fraction there. Okay. We could go on and do the cosine or the tangent here by thinking about the other SOHCAHTOAs, but I think the hardest part is getting the triangle drawn and labeled. After that, the SOHCAHTOA part usually is the easier part of the problem. So let's look at another one for drawing and labeling. And let's say that I want to do the sine of 4 pi over 3. Okay, so radians. 0, pi, and we're cutting pi into 3 pieces. So I want to cut the top half of this circle into 3 equal pieces. When you do this, that vertical line is actually a distractor, because if I want to cut it into 3 pieces, that vertical line is not one of those pieces. I've got 1 piece here, 2 in the middle, and 3 over there. Then on the bottom, same thing. 4, 5, 6. Okay, so we cut each half of the circle, each pi radians, into 3 equal pieces. Then that top number tells me how many pieces to go. It tells me to go 4 pieces around the circle. So I'm going to start at my 0 line and I'm going to count 1, 2, 3, 4th piece. So I found my angle here, and I'm going to connect that to my x-axis every single time, x-axis every time. Now I want to think about how big are these angles. Well, if I cut a pi, or 180, into 3 pieces, 180 divided by 3 is 60. So this is a 60-degree angle. So this is a 30, 60, 90 triangle. Across from the 30, which would be that angle down at the bottom, is the 1. The hypotenuse is 2. And across from the 60 is a square root of 3. Horizontally, this is on the left on our graphs, so that's a negative for the horizontal 1. Vertically, this is on the bottom of the graph, so that's a negative for that square root of 3. Hypotenuse, always positive, no matter what direction it looks like it's going. Okay? Then we are ready to SOHCAHTOA. When you SOHCAHTOA, you are always focusing on that origin angle, so we are focusing on the 60. So when we focus on the 60, sine opposite over hypotenuse, we get opposite is negative square root of 3, and hypotenuse is 2. Okay? We could go on and do the cosine or the tangent, but I think graphing the angle is, again, the hardest part of the problem. So let me know what questions you have as you are working through this. I'm happy to help through email or through Google Meets, whatever works best to get your questions answered. Talk to you later, guys.